Welcome to Serene Science, a place for stress-free learning. Today we're going to take a deep breath and focus on common chemistry calculations related to stoichiometry. If you need a break from studying, I have a series of guided meditations on this channel that can help you relax and refocus your mind, so check those out if you wish. Now let's get started with our calculations. So the type of calculations we'll be looking at are mole-to-mole conversions, gram-to-mole conversions, or mole-to-gram conversions, moles to molecules, atoms, or ions, or the reverse, so molecules, atoms, or ions to moles, and then we'll wrap everything up with grams to grams calculations. Let's first look at a mole-to-mole calculation. So this problem asks, how many moles of ammonia can be produced from 6.00 moles of hydrogen reacting with nitrogen? And then a balanced chemical equation is given to us. Before we begin solving this problem, let's make sure we understand the substances that are named in the problem and how they correspond to the formulas given in the balanced chemical equation. So ammonia has the formula NH3, hydrogen has the formula of H2, and nitrogen has the formula of N2. Okay, so now we're ready to start writing down what we know from the problem. So we know that we have 6.00 moles of hydrogen, H2. We also know the balanced chemical equation, which will be important for solving this problem. We'll also write down what we're solving for. So the question asks, how many moles of ammonia? So that means we're solving for moles of NH3. I am using the abbreviation for moles, which is MOL, so I'm not missing letters, I'm just using the abbreviation. Next, let's come up with a plan to go from what we know to what we're trying to solve for. So we're going to go from moles of H2, and we want to get to moles of NH3. Conveniently, there's a conversion factor that allows us to go from moles of one substance in a reaction to moles of another, and it's called the mole ratio. And the mole ratio is related to the balanced chemical equation. Specifically, we're going to use the coefficients in front of H2 and the coefficient in front of NH3 to solve this problem. So let's set it up. So I'm going to use dimensional analysis, or sometimes referred to as factor label method, to solve this problem. So you always start with what you know. So we know we have 6.00 moles of H2. And then we set up a grid that's showing multiplication of conversion factors. So our conversion factor here is going to be our mole ratio. And like I said, we're going to use the numbers or the coefficients in front of H2 and in front of NH3 to set up our ratio. So I want to put units of moles of H2 in the bottom or the denominator of my problem so that my units of moles of H2 cancel. So I'm going to put 3 moles of H2 in the bottom. The 3 is coming from the 3 coefficient in front of H2 in the balanced chemical equation. And I'm going to put moles of NH3 in the numerator or on top of my ratio, because that's what I ultimately want to solve for. So I'm going to put 2 moles of NH3 on top. When I set my problem up like this, my moles of H2 are going to cancel, and I'm going to be left with moles of NH3. Now I'm ready to plug it into my calculator and figure out the answer. And it would come out to be 4.00 moles of NH3. Let's try a mole to grams calculation. And this one asks us, how many grams are in 2.00 moles of NH3? So again, we'll start by what we know. We'll start by writing down what we know. So what we're given is the 2.00 moles of NH3. And then we'll figure out what we're trying to solve for. The problem asks how many grams, so we're solving for grams of NH3. And there is a conversion factor that allows us to, in one step, convert from moles to grams, and that is called the molar mass. So we can go from moles of NH3 to grams of NH3 by using molar mass. Molar mass is calculated using the periodic table. And I have a video on how to calculate molar mass, so I encourage you to check that out. But for right now and in this problem, I'm going to just have the molar mass available. But just know that oftentimes you are asked to calculate that on your own. Okay, so now I'm going to set up my dimensional analysis problem. And I always start with what I know or what's given to me. So that's the 2.00 moles of NH3. Next, I'm going to use the molar mass to get to units of grams of NH3. Molar mass has units of grams over moles. And for NH3 ammonia, that value is 17.03 grams of NH3 in 1 mole of NH3. Since it is a conversion factor, we could flip it over to get our units to cancel out if we needed. But the way it's written here is correct because our units of moles of NH3 cancel out nicely. So we have a value with moles of NH3 in the numerator at the top, and we're multiplying it by the molar mass, which has units of moles of NH3 in the denominator. So those units cancel and we're left with grams of NH3. Next, we'll plug this into our calculator to get our answer. And we end up with a value of 34.1 grams of NH3. Let's look at another example. Let's do a moles to molecules example. So this question asks, how many molecules are in 4.50 moles of H2O? Once again, we'll start by writing down what we know. So what's given to us is the 4.50 moles of H2O. And from the problem, that's the only information we can directly draw. What are we trying to solve for? It asks how many molecules, so we're solving for molecules of H2O. So we're going to go from what we know to what we're trying to solve for. So our plan here is to go from moles of H2O to molecules of H2O. To do this type of conversion, we're going to use a special number called Avogadro's number. And that number is 6.022 times 10 to the 23rd. The way we use it as a conversion factor is we can say that there are 6.022 times 10 to the 23rd water molecules in 1 mole of water. We could also say there are 6.022 times 10 to the 23rd elephants in 1 mole of elephants. It could be any substance, but since we're dealing with water in this problem, we're going to use the units of molecules of water per 1 mole of water. Okay, so that is the number that we use to solve this sort of problem where we go from moles to molecules. So let's set it up and see what it looks like. So we'll start with what we know, the 4.50 moles of H2O. And we know there are 6.022 times 10 to the 23rd molecules of water in every 1 mole of water. My units, moles of water, will cancel, and I'm left in units of molecules of water, which is what we're trying to solve for. So now I'll plug this into my calculator and get a final answer. And I end up with 2.71 times 10 to the 24th molecules of water, H2O. And that's the final answer. Let's look at one more really common type of conversion, and that's a grams to grams calculation. Before we dive into that problem, I want to draw your attention to the guide that's in the bottom left corner of your screen. So this is kind of a summary of what we've been doing so far, and also how we're going to tackle our grams to grams calculation. So if you look at the guide, we have substance A and substance B, and we have some relationships between them. So for example, we could do the moles of substance A to the moles of substance B using the mole ratio, which we see right here on the chart. We also have relationships between moles and grams, so I can go from moles of a substance to grams of a substance using the molar mass, which we see right there on the chart. And then I can also go to moles of a substance to the number of atoms, molecules, or ions of that substance as well, using the Avogadro's number, which we see here and here on our chart. Now to go from grams to grams, and the type of problem we see up at the top of the screen, we're going to use this guide. And the question says, how many grams of oxygen are required to produce 25.0 grams of water? And then the balanced equation is given to us. So for this type of problem, the balanced chemical equation is a must. We have to have it in order to solve. So again, I'm going to write down what I know. So I know that I have 25.0 grams of water, H2O. I also know the balanced chemical equation. What am I trying to solve for? It asks me how many grams of oxygen, so I'm solving for grams of O2. That's the formula for oxygen. And to come up with the plan to go from grams of water to grams of oxygen, I'm going to use the guide. So I'm starting with grams of a substance, and we'll call that substance A. So H2O is our substance A, and it would be right here on our chart. So our plan, grams of H2O. From there, we're going to go to moles of A, which would be moles of our H2O. And we're going to do that using the molar mass. Okay, so now we're right here on our flowchart or our guide. And once we're in moles of H2O, we can go to moles of another substance, or B, moles of B. Since we're trying to solve for oxygen, we'll have our substance B be oxygen. So I can go from moles of H2O to moles of O2. And that puts me right here on our guide. To make this conversion, I'm going to use the mole ratio. Next, from moles of O2, I could go to grams of O2, or I could go to atoms, molecules, or ions of O2. But since the problem is asking for grams of O2, that's where I'll go next. Grams of O2. And to do that, I'm going to use the molar mass. Alright, so if we look at our chart or our guide, we are going to span this part of our guide. We're going to go from grams to moles using molar mass, moles to moles using the mole ratio, and then moles to grams using molar mass. Okay, so let's work this out. So I'm starting with the mass of water that was given to me, which was the 25.0 grams of H2O. Then I use the molar mass of water, or H2O, to get to moles. Again, if you need help calculating molar mass from the periodic table, please watch the video I have. But for right now, I've already solved that for us. So I know that the molar mass of water is 18.02 grams of H2O per 1 mole of H2O. Molar mass is a conversion factor. It relates grams and moles. So that's one way I could write it. Or I could flip it over and have units of moles on top and grams on the bottom. And that's actually the form we're going to use here because we want to solve for moles of water and we want to get rid of our unit of grams of water. So I'm going to write this as 1 mole of H2O over 18.02 grams of H2O. When I do that, my units of grams of H2O cancel out, and I'm left in units of moles of H2O. Next, I'm going to use the mole ratio to go from units of moles of H2O to moles of O2. Mole ratios come from the balanced chemical equation, so I will be using this to set it up. I want to get rid of my units of moles of H2O, so I'm going to put that unit on the bottom. And I want to solve for moles of O2, so I'm going to put that at the top or in the numerator. Next, I'll go to my equation and I'll see that there's a 2 in front of H2O, so I'll put a 2 in front of the unit mole of H2O. And there's nothing written in front of the O2 in my equation, so that's an understood 1. So I'll put 1 in front of moles of O2. Now my units of moles of H2O have canceled out, and I'm left in units of moles of O2. I just have one more step to get my final answer, and to go from moles of O2 to grams of O2, I'm going to use molar mass. The molar mass of O2 is equal to 16.00 grams of O2 per 1 mole of O2. Since I want to solve for units of grams of O2 and I want to get rid of the unit mole of O2, I'm going to plug it into my equation just as I wrote it. So the grams of O2 go on top, and the moles of O2 go on the bottom. And so my units of moles of O2 have canceled out. I'm in units of grams and I'm ready to solve. So then I'll plug this into my calculator to get a final answer. And I end up with 11.1 grams of O2. And that's the final answer. So please watch my other videos. I'll have extra practice problems on stoichiometry calculations, along with a video on how to calculate molar mass and also how to balance chemical equations.